Welcome back, class. This is chapter 9. This is one of my favorite chapters in this whole class because this whole chapter discusses capital budgeting decision models. These are real everyday models that chief financial officers, chief executive officers, small business owners, you name it, use to figure out whether or not a project that's being considered will be profitable on the front end. And so there are 6 different decision models. In this video, we're going to go over the first 3, and then in the next video, we'll go over the second 3 because each one gets a little more complicated, and I don't want all of that to be in one video. It could be very long. All right, so hopefully at this point, you have already read section 9.1. 9.1 discusses a few different things. It should explain what capital budgeting is. It should differentiate between short-term and long-term budgeting decisions. And now we should be approaching section 9.2 in the chapter, which is what, is your introduction to your first decision model, which is also just so happens to be the easiest one. It's called the payback period method. Okay, so I'm going to demonstrate an example of how to do this first decision model using an example from your book. Okay, so let's check this example out. And as I always promise you, I'm going to try to tell you the buzzwords that you need to be looking for when you're doing these problems. And hopefully that will help you understand how you solve each one of them, because obviously they're not all going to be the same. All right, so let's do this. So let's say the owner of Perfect Images Salon is considering the purchase of a new tanning bed. So that's their project, right? Their project is, I'm thinking about purchasing a new asset for my business. Okay, so the business owner knows that it's going to cost $10,000 to purchase this tanning bed. So we need to know that. It's going to cost us $10,000. And it's likely going to bring in after-tax cash inflows of $4,000 in the first year, $4,500 in the second year, $10,000 in the third year, and $8,000 in the fourth year. Okay, so we're getting a lot of information. Before we get overwhelmed, let's just keep reading to see what we're going to be asked to do with it. So the firm has a policy of buying equipment only if the payback period is 2 years or less. So the payback period must be 2 years or less. So then our job as the financial officer is to calculate the payback period of the tanning bed and then state whether or not the owner would buy it. Now, one thing that you need to know about capital budget decision models is that every model is going to have what we call an accept or reject decision, okay? Accept or reject. And in this case, that decision with this model is right here. So basically, if we can pay off this investment in 2 years or less, right, then we will accept the project and move forward. If we cannot, if it takes, if it's greater than 2 years, then we will reject the decision, right? And we'll say, nope, not profitable, too much of a risk, so we're going to move on from this. And this is exactly how financial officers and business owners make decisions every single day. That's why I enjoy finally getting here. We've gone through a lot this semester, and now we're finally getting to kind of see how everything that you've learned, how you can pull it all together and make real decisions in the real world. So I love it. Okay, so let's look at how we solve this problem, okay? So in this problem, we're told some information. Let's start to kind of document this information. So year 0, it just means now. That's just a fancy way of saying now. And then I'm told about more information that I'm going to receive, looks like through year 4, right? So I have year 1, year 2, year 3, and year 4. Okay, so what information am I being given about each one of these years? Well, I'm being told cash flows, right? So I'm going to say cash flows. All right. So in year 0, which is now, what cash flow would I have? Well, I have to make an initial investment, right? And that initial investment is the $10,000 I have to spend on the tanning bed. So at year 0, I'm going to spend $10,000, which is negative, okay? And then it says in the first year, I'm going to get $4,000 back for my investment, okay? In year 2, I'm going to get $4,500, okay? Year 3, I'm going to make $10,000, and year 4, $8,000. All right, so now we have a table, if you will, that tells us, what our cash flows look like. And then we're asked to use the payback period method to determine if we should accept or reject this project. So what the payback period method does is very simple, actually. Basically what it does is it just says how many years does it take, based on the information that I have, to get my money back that I originally spent, right? So I originally spent, let's go pink here. I originally spent a negative $10,000, right? And so I'm in the red, if you will. And so the question is how long will it take me to get to the black, right? Hopefully everybody understands what that means. Those are accounting terms, but just basically I'm in the negative, and how long will it take me to get into the positive? Now, the interesting thing about the payback period method, the initial method, is that it doesn't account for the time value of money. So we're just talking about real dollars, right? And so basically, we're just going to do very simple arithmetic to see how long it takes, right? So in year 0, I have spent negative $10,000, okay? So I have negative $10,000, and in year 1, I'm going to get $4,000 of the $10,000 that I spent back, right? And so that's going to bring me to negative $6,000, right? And then in year 2, negative $6,000, I'm going to earn $4,500. So I'm going to add that $4,500, right? And then that's going to leave me with negative $1,500. So I haven't quite earned my investment back just yet. So then in year 3, I don't actually need that whole 10 grand, do I? Because in year 3, I have $1,500 left of my investment that I need to earn back. And if I move forward with the 10 grand, it's going to push me way into the positive. That's not exactly what the payback period wants to know. It wants to know how much of year 3 is necessary to get me to 0, right? Well, that's pretty simple, because if I say, well, what does it take to get me to 0? I think most students would be able to say, well, that's easy, Mr. B, it's $1,500, right? So the question is how much of that $1,500 is proportionate to the full year's earnings for year 3? And so all we have to do is just put it in a fraction. So if I take $1,500 and divide it by 10,000, right? Then I'm going to get 0.15. And so what I can do is I can say, well, in year 3, it didn't take me 100% of all the earnings that I needed from year 3. It only took 15%, or 0.15, right, as a decimal. And so the answer is that if I'm conducting the payback period decision, come down here, then what I've determined is that it will take 2.15 years to earn my investment back, which is greater than 2 years. And since it is greater than 2 years, remember up here, we said that if it's greater than 2 years, then we reject the decision, right? So our ultimate decision here is to reject. Why? Because it takes more than 2 years to earn our money back, okay? So that's how you use the payback period method. It's actually quite simple. Your publisher, your book, wants you to solve for the fraction here. I guess just to make sure that you can do some arithmetic, but in all reality, the second that we realized that it was going to take more than 2 years, right here, the second we knew it was going to take more than 2 years, we could have stopped right then and there and said, you know what, reject it, because even though we don't know exactly the fraction, we do know that it's beyond our accept or reject decision threshold that we've established for ourselves, because we established it at 2 years or less. And we could have just stopped right there, but of course, when you do your homework or your quiz or your test, it's going to ask you, to be able to finish up that math. All right. So moving right along, you might have noticed that I said during example 1 that one of the flaws with the payback period method is that it does not incorporate the time value of money. And I hope by now, after 8 chapters and nearly 3 months, almost 4 months of this class, I hope everyone watching this video understands the importance of the time value of money. And so, through time, financial managers realize that, hey, the payback period method doesn't really work that great unless we somehow incorporate the time value of money into that method. And so what we're going to do is we're going to kind of do the exact same thing that we just did, except we're going to bring the time value of money into it, and I'm going to demonstrate how to do that. But this is the second method that is used by financial managers, and it's called the discounted payback period method. All right, and we're going to try to use the same numbers so that way there's not too much new information. All right, so just very quickly, I'm going to write those same numbers down again. So we have year 1, 2, 3, and 4. We have an initial investment of $10,000. We're going to have, let's see, $4,000 in earnings year 1, $4,500 year 2, $10,000 year 3, $8,000 year 4. Okay, so now you might ask, well, how do you incorporate the time value of money into this method? Like, how does that work? Okay. Well, as I told you earlier in the semester, I'm going to avoid algebra as much as possible because I know a lot of students taking this class are not fans of it. You want to be able to solve the problem but not have to worry about all the technical mathematical terms. So that's how I'm going to approach this. If anybody in this class ever wants to see it algebraically, I'm happy to publish another video or work with you one-on-one. So please just let me know that. But for the purposes of this one, for the whole class, I'm just going to demonstrate how to solve it with your calculator, okay? And the main piece of information that we needed to know that we weren't originally supplied with is this second sentence here. It says the required rate of return set by Perfect Images Salon is 10%. So what does that tell us? Well, let's put our thinking caps on for a second and let's realize something, right? The cash flows that we've been given. So let's change colors here so that I can write in a different color. These cash flows here that are being given to us are not in today's dollars. Well, except for year 0. So year 0, those are the only cash flows that are actually in today's dollars. But when I'm projecting that I'm going to make $4,000 in year 1 or $2,000 in year 2, $10,000 in year 3, and so on, basically what I'm saying is that's a future value, right? So if we remember our equation for the time value of money, our equation states that the future value of any sum of money is equal to the present value, right, times 1 plus the required rate of return or the discount rate raised to n, and n is the number of pay periods, all right? And so basically if we think about this on a timeline, right, if I draw a timeline, I'm being given today's dollars, right? But I'm also being given future dollars. Okay, so I have, 4,000, I have 4.5 thousand, 10,000, and 8,000, right? And these are future dollars here. So once again, just making sure we're all on the same page, these are future dollars. And since they're future dollars, they're not really in today's terms. And one of the most important things that we learned in chapters 3 and 4 when we were learning about the time value of money is that to compare cash flows, you really have to discount everything back to the same date, or you have to compound everything forward to the same date. But the most important rule is that everything is standing at the same point in time, right? So if we look at this timeline here, the most important rule is that everything has to come back to one point in time. So all of these flows, cash flows, they all have to come back to one point in time, which is today, because today is the day that we're making our decision, right? So we're making our decision right now, and so that is present day or present time. And we need to know what the values of these cash flows are in today's dollars, all right? And this is actually not as complicated as it appears, basically because we have a handy-dandy calculator that will do most of the work for us. But I just wanted everyone to understand what I'm about to do before I do it. So let's whip out our calculators for a second, all right? Still need to clear that out. Just going to clear my TVM menu. And so remember, for year 0, we already are in today's dollars, so we don't need to do anything to the negative 10,000, but we do need to alter the cash flows for years 1 through 4 so that they are in today's dollars, and that's what we're going to do. So we're going to find the present value of all cash flows, and I'm just going to abbreviate. All right, so we're going to find the present value of all cash flows. And remember, the first one is already in the present value. It's the negative $10,000. But let's move forward from there. So if $4,000 is the future value of a cash flow that I'm trying to figure out in today's dollars, I'm going to set that to FV, right? And luckily, we're not dealing with any payments. So these calculations are just like the basic ones that we did in chapter 3. So we're just going to zero out payments every time. All right. We know that we're looking for the present value, so I'm going to skip over that. 10% is my required rate of return, which is my interest rate. All right. So I'm going to put 10 and assign it to IY. And then I need to know how many pay periods. Well, in this case, we're working with years, and compounding has not been mentioned at all in the problem. So we're going to assume that our pay periods are years. And so for that first cash flow, I'm just going to say 1 for N. And now that I have all of my TVM keys assigned except for 1, I'm going to hit compute present value. And now I see that if I was to discount year 1's cash flows, they would actually be closer to $3,636 and let's see there, 36 cents if we go ahead and round. Okay, so far so good. And we have to do this for each cash flow. So I'm just going to kind of move through these, and hopefully you'll be able to kind of keep up, or you can hit pause if you need to. But I'm just going to move through because we're going to do the same thing every single time. So 4,500, future value, 0 is payment, 10 is my I over Y, and this is the cash flow at year 2. Compute present value, and I get 37.19, and if we round, 1 penny. All right, and then we're going to go 10, future value, 0, payment, 10, I over Y, and 3 for our N. Compute present value, we get $7,513.15. All right, and then one more time, we're going to say 8,000, future value, 0, payment, 10, I over Y, and then year 4, so 4 is in, compute, present value, and we get for that final year, $5,464.11 if we go ahead and round. Okay, so you probably are going to ask me at this point, well, what do we do now? Well, this is where it gets really simple, actually. All we have to do is now proceed with exactly what we did up here. We just proceed with doing the payback period method. The only difference is now all of these cash flows that we started out with, they're all in today's dollars. So they've all been discounted in time, back to time zero, and they're now standing here at the same point in time as year zero, which is today. And so that what that means is we've now incorporated the time value of money into our decision, okay, which is very important because a lot of people who make financial decisions do not think about the time value of money. So all we have to do is just proceed, okay? So the first thing we're going to do is we're going to start out with our investment. So our investment was originally $10,000, and we are going to subtract or add, because it's a negative, and we're going to add a positive cash flow of $3,636.36. Okay? Actually, I don't like how this is working out. I'm going to rewrite that so it fits. So 10. There we go. That's better. All right. And so that's going to give us, let's see. $63.64. Whoops. All right. So that's year one. So we still, we already know that we haven't recovered our investment yet. And remember from example one that our accept reject decision is X must be less than or equal to 2 years, right? So far, we still haven't recovered it. So we're going to start there again. All right, so this is year two. Plus 3719.01. So that gets us to 264464. Did I write that? Oh, 63, sorry. There we go. All right, and so like I said before, honestly, in real life, we would just stop because this right here already tells me, it already tells me that since I have not recovered my value in 2 years, that this decision should immediately be a reject decision. So honestly, we already know that we're going to reject this project based on the parameters that were given to us by Perfect Images Salon, okay? But your book wants you to take it a little bit further, and so that's what we're going to do. We're going to actually finish doing the math, all right? So we're going to take negative 264463, and we get to the third year. The third year is the 3719. Excuse me, no. So, my apologies. I'm reading the wrong line. It is the 7,513. Okay, so we let's stop for a second. So once again, we are faced with the same scenario that we faced in the first example. And what that is our next cash flow, we don't need all of it, do we? And so it's very easy to answer the first part of this. So how much do we need? Well, if we're negative $2,644.63, then that's exactly how much we need, right? To go to zero, to suddenly pay off our investment. So we already know that that's how much we need, but that's not... that's much less than the cash flow in year three, right? So we need to figure out what portion of year three it would take to finish this off, which is kind of like just making a fraction like we did the first time. So we're going to put that over 7,513.15. and that tells us what portion of year 3 that we would need to get to year 0. So we're just going to divide that by 7513, 15. And you can ignore the negative. I just didn't make the last answer positive. And if we go ahead and round to 2 decimal places, that's 0.35. All right, so 0.35. So that means that it is going to take 2.35 years using the discounted payback period method to recover our initial investment. And as we already stated, with a accept-reject criteria of 2 years or less, we already know that 2.35 years is too long, and since it is too long, we're going to reject the decision. Okay, so that's how you do the payback period. That's how you do the discounted payback period. And there's one more that I want to squeeze in on this video, and this will become your new best friend because it is the most popular decision method that is used. And we're going to talk about how to use it with one project, and we're going to talk about how to use it with more than one project. All right, so it's called the net present value. Net present value. And it's really easy to use. All you have to do is know about the secret menu on your calculator that I'm going to show you. And once you know about it, you fly by, right? It's really neat. So what the net present value method does is it kind of takes the discounted payback period method a step further, because you'll notice that we never even used this information, did we? We got to year 3, and once we got to year 3 and paid off the investment, we just stopped. Well, the net present value method basically takes it one step further, and it says, well, let's see what the total net present value is of all cash flows, right? Because you're basically still discounting all future cash flows to the present value, and you're adding them all up to see what the total value is. And the reason why we love this decision is because it has a very, very simple accept or reject criteria. So when you're doing the net present value, all you need to know is that the accept criteria is that the final answer must be greater than 0. And as long as it's greater than 0, then you approve, you accept. And if it is the reject criteria, is if it's less than 0. So if it is, I should have said, if it's greater than or equal to 0, then it is considered to be a profitable project. If it's less than 0, if the answer to what we're about to do is less than 0, then you reject it. And it truly is that simple. So I'm gonna try to give us some space here. Let's see. Looks like we had a little, whoops, of course that would happen. Great. Well, now I feel silly. Let's see what I can do about that. I'm sorry, guys. This is a little hiccup. I did not realize that those were going to overlap like that when I set this all up for our video. So I'm going to leave that alone. Don't worry, we'll make it work. Okay, I'm just going to leave that alone for now. Okay, so how do we do net present value? Well, as you saw earlier, the whole point is to incorporate time value of money. So conceptually, I'm just going to show you something. We are basically doing the same thing. So we have cash flow at time 0, cash flow 1, cash flow 2, cash flow 3, cash flow 4. And we know that cash flows 1 through 4 are future values. And just like the name tells us, what we're looking for is the net present value, right? And so what we're doing is we're going to discount all of these cash flows back to time 0, and then we're just going to add them all up, because that's what net means, right? Net just means adding everything up. So once they're all at the same place in time, we just add them up, and we just figure out what the sum is. So the net present value is the sum of all cash flows in present value terms. Okay, so you might ask, well, how in the heck am I going to do that? It sounds like a lot of work. Actually, it's not that much work, because there's a menu that is hidden in your calculator that will solve for this without you having to do very much work at all. Okay, and so I'm going to whip your calculator out, and I'm going to show you where that is. So in your menu, if you look right beside the second key, there is a key, like right beside this key right here. There's a key right next to it that says CF. Well, that key is your cash flow menu. So let's explore that menu for a second. So when I click the button, CF, the first thing that comes up is CF0. Now, before we start putting anything in there, let's just explore this menu. You'll notice that at the top of your calculator screen, there's up and down arrows. So we're going to use the up and down arrows beside the help button to let us navigate this a little bit. So if I go down, look at there, it says cash flow 1, right? C01. If I go down again, it says F01. So what does the F stand for? The F stands for frequency. Now, in the beginning, we're just going to skip over using frequency because that's an option that is for more complicated problems. But just know that frequency should be left at 1 for these more simple problems, all right? And so I'm going to now demonstrate exactly how we can use this menu with this problem. And luckily, I've got the numbers written for this problem right down here for the next part of our problem, which is going to add an extra step. But for this first step, let's just find the net present value of the project that we've been evaluating this whole time. All right, so here's what I'm going to do. It says the calculator is saying, okay, what is the cash flow at time 0? Well, that's easy. I'm just going to type it in. It's $10,000, right? And I have to make sure I make that negative. And then you'll notice that as I typed that in, my equal sign went away. And the way I put it back is the same way I put it back with the TVM keys. I just hit enter. So when I hit enter, that is the calculator confirming that the cash flow at time 0 is negative $10,000. And then I'm going to hit the down arrow, and it's going to say, okay, what is the cash flow at time 1, right? And we already know that. So at time 1 or year 1, the cash flow is $4,000. And I'm going to hit enter, and that assigns it. Down, I'm going to hit the down arrow, and it's going to say, is there multiple cash flows in year 1? Is there more? Does it happen more times than once? No, it doesn't. The frequency is 1. So we just leave that alone, and we're going to hit down again. So now it says, okay, what's the cash flow at year 2? Well, that's easy. I'm given that information. It's $4,500. And then I'm going to hit enter. Down. Oh, what's the frequency of the second cash flow? It's just 1. It happens 1 time. So we're going to go on to cash flow 3. All right, for cash flow 3, it's $10,000, right? Hit enter. I'm going to say that it also only occurs 1 time. The frequency is 1. So moving right along, cash flow year 4, $8,000. Hit enter, and the frequency is 4. And we're out of cash flows at this point, right? So we have now filled out our cash flow menu. We don't need to go to cash flow 5, so don't do anything. If you hit enter there, you're going to mess up your calculations. Just go back up to where you were. And at this point, you're going to say, okay, well, what's the next step? Well, you'll notice that right beside the cash flow menu, the CF menu, there's a button that says net present value, NPV, right? And so I'm going to hit that button. And it'll come up and it'll say I equals. You're going to say, well, what's I? Well, as a matter of fact, it stands for interest rate. Isn't that neat? It stands for the interest rate. And we know what the interest rate is because it was already given to us, right? It was given to us as 10%. So I'm just going to tell the calculator the information that it's asking me for. I'm going to say, okay, it's 10%. And as you notice, the equal sign goes away, and I have to put it back. So I'm going to hit equals. And I'm going to hit enter, and that's going to put the equals back, sorry. Okay? And then I'm going to hit the down arrow, and it's going to say NPV equals 0. Well, that's because I haven't told it to compute anything yet. So what I'm going to do now is I'm going to hit compute because I want it to compute the net present value for me. So I'm going to hit compute, and boom, it tells me that the net present value, oops, got to change back to a pencil. The net present value of this project is $10,332, and if we go ahead and round, 63 cents. And so what does that mean? It means, let me move my calculator out of the way for a second. It means that if we discount all cash flows, right, back to time 0, and then add them up, right, that the net present value, when we add them all up, is this amount. And the question then remains, is that amount greater than 0 or is it less than 0? Well, in this case, it is greater than 0. And so if we are using the net present value decision model, we would accept this project. And it's that simple. It really is that simple. Now, in your book, it teaches you the algebraic method. Like I said, I don't want to make things super complicated on you. And so I've decided not to demonstrate it algebraically, but I'm happy to do so for anybody that wants to see it that way. Please just let me know. Okay, so we're not quite done yet. There's a few more examples that you need to see because in real life, it still isn't quite this simple. So let's look at this next problem here so that you can see a real life example of how somebody might be entertaining this decision. So your book discusses a vocabulary word called mutually exclusive projects. And basically what this terminology means is that oftentimes managers or business owners are faced with more than one option. And so when you're looking at two different options, oftentimes you're only wanting one solution. All right. And so we call that having mutually exclusive options because if I choose one, I'm not going to choose the other. Right. I'm only going to choose one. And so the question then becomes, well, which one do I choose? Well, in this case, Perfect Images Salon is entertaining the idea of buying a tanning bed or a tanning booth. Okay. And so what we've done is we've figured out what the cash flows would be for each. So then the question is, now that we know the cash flows for each and we know how to conduct a net present value model or decision, a net present value decision model, then how do we know which one to take? All right. So in this case, what financial managers recommend is to select, oops, I did it again. Sorry, guys. We want to select the option with the highest net present value, okay? So whichever project has the highest net present value, it is also the most profitable. So because it's the most profitable, okay? And so the neat thing about this example is that we've already calculated the net present value for the option A, if you will, like for the first option, for the tanning bed. So we know that the net present value for the tanning bed is $10,332 and 63 cents. Okay, so all we really need to do, right, is we just need to, I'll just put TB. Well, they're both TB, aren't they? TBA and then TBB. How about that? So TBB NPV. We just need to go back and do the same thing that we just did to see what the net present value would be for the tanning booth, right? So let's pull our calculator out. I'm going to shift it over here so you can see what I'm doing and see my numbers. All right. So all I'm going to do now is I'm just going to clear my cash flow menu. Now, on your calculator, it might be in a different place than mine, but you're going to hit second, and then you'll notice that down there where you normally would see CEC for clear whatever's on the screen, now it's clear work for your secondary menu. So I'm going to hit that. And what that's going to do is it's going to clear my cash flow menu out so that I'm not working with old numbers, I'm working with new numbers. So when I go back to my cash flow menu, well, darn it, that did not clear it. Let's see if that worked. Hold on. There it goes. So you have to be in your cash flow menu. So you want to go to the menu and then hit second, clear work, and that will clear it out. So that way you know you're starting with a clean slate. Okay? But then from there, it's really easy. I mean, we can breeze through these types of problems. We just have to look at, okay, what are the cash flows that we are dealing with for the tanning booth? Because that's the other project that we're evaluating. And so for the cash flow at time 0, 12,500, make it negative, enter. Down to cash flow year 1, 4,400, enter. Skip the frequency, cash flow year 2, 4,800, enter. Skip the frequency, cash flow year 3, 11,000, cash flow year 4, 9,500. And at this point, we're going to go to the net present value menu, and it's the same discount rate. The discount rate has not changed. It's 10%. I'm going to go down one time, and I'm going to hit compute. And now I know that the net present value of a tanning booth is $10,220. And if we go ahead and round, 3 cents. All right, so let me get rid of my calculator for a second. So now what we have is we have a comparison. And when we look at Project A versus Project B, and we're told that we are supposed to select the option with the highest net present value, what we know is that Project A is greater than Project B, and so we should select, if we are comparing these two options, not only should we accept either of them if we're just looking at singular net present value, accept reject decisions, but if we're comparing them as mutually exclusive projects, then we should select Project A because it has a slightly higher net present value, and that also means that it is the more profitable venture. All right, so I wish that I could tell you that we're done, but we're still not quite done. There is still one more situation that managers run into, still kind of in the same vein. We're going to stick with the same numbers. The only difference here is that there's a difference in life. And so that's the last example that we're going to work for this video. If you need a break, just hit pause. I know that I've been going for a while, but I want to squeeze this one in because this is the first 3 models of chapter 9, and then the last 3 we'll do in another video. And so what happens in real life is that oftentimes when managers are comparing different options, they run into situations where the life of an investment is longer or shorter than the life of another investment. Okay? And so then the question becomes, well, if the lives are different, how do we compare them? Because that's not quite the same, is it? You know, in our last example, they had equal lives. You know, you made an investment, and that investment had 4 years of cash flows. But in this case, we're going to see an instance where we have mutually exclusive projects with unequal lives, and that changes things a little bit. And there's 2 different ways that we can solve it. I'm going to demonstrate both of them. I will tell you one method is much, much easier to use than the other method because one method uses algebra and the other method does not. So I would recommend using the one that doesn't have algebra in it, but totally up to you. I'm going to demonstrate both in this video. So again, if you need a break, hit pause and then come back and join us. Okay, so let's say that now we've decided that we're going to get a tanning bed for sure. We know that the tanning booth is out, but we're looking at 2 different tanning beds now. So we're looking at the one that we initially looked at, but then we found out, hey, there's this other one that costs way less, right? but its shelf life, if you will, is also less. So basically what we're saying is the initial tanning bed that we looked at was a premium tanning bed. Now we're kind of looking at a cheaper option, which is tanning bed B, right? And tanning bed B will not last quite as long. It only lasts for 3 years, but it's way cheaper, right? It's way cheaper. So that's kind of what we're looking at here is like, again, if we're in the red 10 grand with tanning bed A, but we're only in the red 5 grand with tanning bed B. That's a huge difference, isn't it? And it's hard to compare these two things because they have different lives. And since there's different lives, we have to have some type of method or approach, if you will, at being able to compare them appropriately. All right. And so the owner realizes that she's going to have to replace either of the beds with new ones when they hit the end of their life, because she's not expecting to close her business or close up shop when these products stop working. She's just going to have to replace them, right? Because she plans to be in business for a long time. Well, don't we all? Right? And so what we're going to do is we're going to look at some different options on how you can compare mutually exclusive projects that have different lives, because you're trying to ultimately make a decision as to which one's going to be the most profitable for your business. All right. And we're going to keep the same cost of capital at 10%. And so let's dive in. The first method that we can use is called the replacement chain method. And I've already got our cash flows written out there for you. But here's what the replacement chain method basically does. The replacement chain method uses algebra, and it basically says, okay, we need to find the net present value of each project. And then once we find the net present value of each project, we need to figure out how many times these investments will need to be replaced until we find an equal point in time where they would both be replaced at the same time, right? And that's tough because it's kind of going back to arithmetic and looking for the lowest common multiple. I'm not sure how many of you remember that term. There were two terms that you would have learned at some point in high school. One of them was called One of them was called the greatest common factor, GCF. The other one was called the lowest common multiple. And I'll tell you how we're going to use that here in a moment. But I think the first thing that we need to do is we need to find the net present value of both projects. And we already know the net present value of the first one, don't we? So the net present value of A, we already know, if we go back up here, was $10,332.63. All right, so we're going to get some more practice on how to do the net present value of another project right now. So we're going to find the net present value of the second tanning bed. I'm going to move my calculator over here. And again, we're going to go to our cash flow menu. We're going to clear that out. Always remember to clear that out. And then we're going to put our figures in that we have for tanning bed B. So we're going to say $5,750. We're going to make it negative because it's an investment. We're going to hit enter. All right, cash flow year one, $4,000. All right. We're going to skip frequency. Cash flow year two, $4,500. Enter. Cash flow year three, $9,000. Enter. All right, and that's all the cash flows we have because that's the shelf life or the expected life, right, of this investment. And so we're going to go to our net present value menu. We're going to set our interest rate to be 10%. And then we're going to go down one more time and hit compute. And we're going to find that the net present value for tanning bed B is $8,367. And if we go ahead and round, 21 cents. And so this is where it gets tricky, because what we want to do, our inclination, is to say, well, we should select tanning bed A because it has the higher net present value. But see, that's not fair, is it? Because technically, tanning bed B didn't have as many years of cash flows to report back to see if it would truly be even or not. It stopped at year 3. So if we look at it on a timeline, let's move this out of the way for a second. If we look at it on a timeline, where can I draw this timeline? I'm going to draw it. Let's see. Let's go back up here. I'm going to go back up here so I don't mess up with my math. So if we look at this on a timeline, I'm going to draw 2 of them. So we have project A, project B, right? And so what's going on is in project A, 1, 2, 3, 4, it's going to live to this point in time. Well, project B only lives to here, okay? And so what happens is the owner, if they went with project B, well, all that would happen is they would reinvest, right? And then they would go out 3 more years of life. So 4, 5, 6, okay? And this is where the lowest common multiple comes in, because we're working on the replacement chain method. And maybe some of you are like, oh, chain, that's why it's called chain method, because I'm about to demonstrate what we're doing here. So what we need to know is we have 2 different projects with 2 different shelf lives or expected life expectancies. One has a 4-year replacement, the other one has a 3-year. And so what we need to find is we need to find the lowest common multiple. We need to find a point in time in the future when both projects are replacing their assets at the exact same moment in time. Well, it's actually really simple in this case. In this case, the lowest common multiple is to take both of these and just multiply them together, right? 12. But I'm going to also demonstrate that visually because I know some people are visual learners. But what I know is that in year 12, we're going to be replacing both of these at the same time, but I'll show you. All right, so this one's replaced every 4 years, so 5, 6, 7, 8, right? And then it's replaced every 4 years, so 9, 10, 11, 12. Well, if we look at project B, it's replaced every 3 years. So if I keep going, 7, 8, 9, 10, 11, 12, right? And so what we find is that the only point in time that a financial manager can actually compare the profitability of both of these projects together, well, there's 2 points in time, right? One of them is at time 0, but we can't use that one because, you know, the different shelf lives or the different life expectancies of these projects aren't quite equal at that point. If we discount just what we know to begin with back to time 0, back to, you know, if we take these and push them back here and these and push them back here, well, that's not exactly fair, is it? And so the question then becomes, well, then how can we make it fair? How can we make it to where we know that both projects are on an even keel? Well, what we have to do is we have to look forward to the future, and we have to look for the lowest common multiple that tells us when both of them are going to be replaced at the same point in time, and that is at year 12. At year 12, both projects will be about to be replaced, and so what we can do is we can look at the cash flows that would be associated with both of these projects all the way through year 12. All right, I hope you're still with me. We're not done yet. There's an extra step to this that confuses a lot of students, so bear with me. All right, I'm going to erase these arrows so I can show you what the next step is. Okay, so now that we have figured out that year 12 is when we need to be evaluating both projects by, we have to figure out what the cash flows that would be associated with both projects out to that point in time. Okay, so this gets a little tricky, okay? Because you have to think about what information are we working with? Well, we already found the net present value. And so we know that the net present value of this project is going to be the same no matter how, or of these tanning beds is going to be the same no matter how many times we buy them. All right, so using the replacement chain method, what I'm going to do is I'm going to say, okay, well, I know that the net present value the first time I buy the project A tanning bed is going to be 10,000. What was it? It was 332.63. 332.63, right? Well, that's the value of the project in today's dollars at time zero. Well, if we use our common sense, when we replace it at year 4, the net present value at year 4, looking forward in time to year 8, is still going to be the same, right? If we were to spend $10,000 here and then have the exact same cash flows for the next 4 years, then the net present value at time 4 would also be $10,332.63. And we can use the same logic to say that the net present value at year 8 would be the same once again. Okay? So basically what we're doing when we use the replacement chain method is we're creating a new set of cash flows that incorporates the net present value, but gets us to an equal point in time with 2 separate but mutually exclusive projects. And so I'm not going to do another one at year 12 because that's my stopping point. So basically, when I repurchase tanning bed A at year 8 and then pull those cash flows back to year 8 to find the net present value of $10,332.63, I'm going to stop there. But then I got to do the exact same thing with tanning bed B. So with tanning bed B, I know that the net present value is $8,367.21. So I'm going to start at year 0, and I'm going to say, okay, it's $8,367.21. And then after 3 years, if I buy it again, it's going to be the same net present value at that point in time, right? All right. And then if I buy it again, same thing. And if I buy it again, same thing. All right, and this is exactly why I use the timeline, because I want you to visually see what's going on. So what's going on here is that if I'm playing, hypotheticals, and I'm the owner of the salon, and I go with project A, I'm going to spend 10 grand, I'm going to spend 10 grand, and then I'm going to get positive cash flows for 4 years. And if I discount those cash flows back to time 0, my net present value is $10,332. And if I decide to do that over and over again, right, then my net present values should be the same as long as my discount rate does not change, right? And so what I've created, you're going to love this, what I've created is a chain, right? These are chain links, all right? This is my replacement chain, okay? And I've done the same thing for Project B. I've created chain links. So for you visual learners, these are my chain links, all right? And so now the question begs, well, we have mapped it out. It's on a timeline. We see the cash flows, but we don't feel like we are any closer to the answer. Well, that's because if you remember, any time that we deal with future cash flows, what do we have to do? We talked about this earlier in this same video. Anytime that we are dealing with future values, we must discount them back to present value. So now that I am dealing with the future value replacement of the net present value that we calculated earlier, I have to now discount all of those cash flows. Let me use a different color here. I have to discount all of these cash flows back to time 0, right? All of them back to time 0. And that's the last step to the replacement chain method, which is the first method of comparing mutually exclusive projects with different or unequal lives. And I'm going to demonstrate that. There's a little bit of algebra, but I'm going to demonstrate it for you. So what I'm going to do is I'm going to come down here and I'm going to rewrite this up. So we have year 0. I'm going to have to do this 2 separate times because the links come up at different times. But for project A, we have year 0, year 4, and year 8. The cool thing is that the cash flows stay the same in this case. So we'll say project A cash flows. All right. And so for the first one, it is $10,332.63 $10,332.63. $10,332.63. All right. And then if we are looking at the second one, project B, the years for that one is 0, 3, 6, and 9, right? And then project B cash flows. Okay, so far so good. And those are going to be 8,367.21 4 times. Okay, and so what we want to find now, believe it or not, what we want to find is the total net present value of all future cash flows using this replacement chain method. Luckily, we don't have to do algebra to do that. We can actually use, once again, the cash flow menu, but you have to be careful. This is where it gets a little tricky. So let me demonstrate, and let's hope that I do it right, because it does get tricky, okay? So I'm gonna go back to my cash flow menu. I'm gonna clear work, and what we're gonna do is we're gonna say at year 0, because it is at year 0, we're gonna say 10,332.63, enter, and this is where it gets a little tricky. There's no cash flow at year 1 any longer. It's not there. It's actually all the way out at year, let me move this back over here. It's all the way out at year 4, isn't it? So what we have to do is we have to hit enter. So that way we're telling the calculator there is no cash flow at time 1 or year 1, and the frequency stays there. Now, we can speed this up if we increase frequency, but I think that's going to confuse folks. If I do that, it's a very difficult concept to grasp of using the frequency, so I'm just going to skip it, and we're going to keep leaving frequency at 1. And so cash flow at year 2, there isn't one. Cash flow at year 3, there isn't one. Oh, here we go. Cash flow year 4, 10,332.63, enter. All right. Cash flow at year 5, we have to keep hitting enter to get it to keep going forward. 6, enter. 7, enter. 8, and we do it one more time. Enter. All right, we're going to go net present value. Discount rate stays the same. Go down 1 and cross your fingers. The total net present value of project A is $22,210 and right around 20 cents. So I'm going to move this over. Come on. Where are you going? There we go. So for project A, using the replacement chain method, it's $22,210.20. And all we have to do is we just do it again for project B. So we're going to go cash flow, second, clear, and starting at year 0, 8,367.21, enter. And then instead of doing it every 4 years, we're just going to do it every 3 this time. So we're going to hit enter for year 1, for year 2, 0, and then for year 3, 8,367.21, enter. All right, year 4, enter. Year 5, enter. Year 6, we're going to put another one in, 8,367.21. Year 7, 0. Year 8, 0. And then year 9 is our final one, 0.21. All right, net present value, discount rate is 10. Compute, and we get 22,000. Let me move this over. So we get $22,925.20. Whoops. I hit that little button there. Sorry, guys. And 20 cents. There we go. So, all right, we did all the math, and this one was kind of math extreme. I know it was, and the crazy thing is this is just the first of two methods, but the other one's not nearly as long. Okay, but this one is normally the one that most students grasp a little bit better, so that's why I wanted to demonstrate it. But now that we have these two, what we know without a doubt is that Project B, or tanning bed B, okay, is actually the more profitable project, right? Because it has the highest, more profitable, because it has the highest total net present value. And we know that because we use the replacement chain method to figure that out, which is actually the opposite of the initial conclusion that we came to, right? The initial conclusion that we came to was that tanning bed A was greater than B, but because the lives were unequal, we had to figure out how to get them on an even playing field, and the only way to do so was to use this method, right? Which is, I know it's a complex method, but hopefully, you were able to pause, rewind, whatnot, to get back and understand that when it's all said and done, that Project B is actually, I don't like really using red, let's use green. Project B ends up having the better total net present value once both projects are being evaluated equally. Okay, so that is the longhand. Actually, that wasn't even the longhand. There's an algebraic way that we could have solved that. I used the calculator. But that still is the longhand way to compare two mutually exclusive projects that have different or unequal lives. The second method is called the, is called the equivalent annual annuity approach. So that's the other method that I'm going to demonstrate. Again, if you're worn out and you're like, gosh, this is just the longest video ever, pause it, take a break, and when you're ready, come back. I'm going to keep going though. All right, so the equivalent annual annuity approach is so much easier than the replacement chain method. All right, so let's look at what this approach basically does. What this approach does is it basically takes the net present value, okay, and it divides that net present value by the present value of annuity factor, this is all the way back from, I want to say this was maybe chapter 3 or chapter 4 maybe. But basically, we find the present value of the annuity factor, which is a piece of an algebraic equation. And once we find that factor, we can divide the net present value by it, and whichever one has the greatest equivalent annual annuity is the one that we should select. All right, so this is the equivalent annual annuity method. All right, so we know the net present values of each project. So we're going to go net present value A, net present value. Net present value A, net present value B. We know that the first one is 10,332.62. And the second one is, let's see here, 8,367.21. And I got to pull up a formula because we haven't used this formula since earlier in the semester. So it's the present value of annuity factor. And that formula, like I said, I think it was mentioned in chapter 4 is when we were first introduced to it. So that is equal to, it's abbreviated this way, present value of an annuity factor. How is it abbreviated? Let's see. I think it's abbreviated as IFA. There we go. So the way that we find that is we put 1 minus 1 plus r, I think that's to the negative n, all over r. I think I'm reading that formula right. Yeah, okay, just making sure I have the right formula. And so we don't need a lot of information, do we, to be able to solve it this way, because basically what this formula does is it takes, let me get my notes back up, it just takes the net present value and it divides it by the PVIFA, and that gives you the equivalent annual annuity approach answer. And so we already know the numerator, or the top part of our fraction. We just need to figure out the denominator, okay? And so for project A, the only two variables that we're missing are r and n. So we know that r is equal to 10%, and we know that n in project A is 4. Same thing for project B, r is 10%, and n is 3. And so we just need to work out this very, very simple equation so that we can go back and solve for that formula there. And this is, this is the much shorter method of comparing mutually exclusive projects with unequal lives. And so we're going to say, okay, so PVIFA, and then, sub A, if we talk about, project A, is equal to 1 minus 1 plus, and remember, when we're doing actual math, we have to convert to a decimal. So that's equal to 0.10, all right, raised to the negative n, which is, n is 4, so negative 4, all right, and then divided by 0.10. And then down here, it's going to be very similar. Negative 3 over. And these are the two things that we have to solve. Very, very quick and easy, right? Quick and painless. So let's pull out our calculator. Let me move it over here so we can see our formula. We're going to clear that out. And remember your PEMDAS. So we have to do inside the parentheses, right? Then exponents. Then we have to make sure that we solve the top and bottoms separately before we divide, right? Because anytime you're working with fractions in algebra, you have to solve everything in the top or everything in the bottom before you divide, okay? So we're going to say 1 plus 0.1 equals 1.1, all right? And then we're going to raise it by hitting that y to the x, right? So raise it to the negative 4, and then we're going to hit equals, all right? And then we're subtracting this amount from 1. So what I'm going to do is I'm going to make it negative and just add it to 1, because that's the same thing. And so that gives me 0.3169. And then all I'm going to do is I'm just going to divide that by 0.1, because that's the denominator. And so for the first part of this problem, the present value of an annuity factor for project A is 3.16. How far do we need to go? Let's go out 4 decimals just to be safe. So 3.1698. All right. So then we're just going to do that again. So for the second one, it's going to be almost the exact same problem. It's just one little change. So we're going to say once again 1 plus 0.1. And this time we're going to raise it to the negative 3. So y to the x, 3 negative. All right. And then we're going to make that negative and add it to 1, because that's the same thing as subtracting it from 1. Okay. And then we're going to divide by 0.1. And we get, what is that? 2.486, we'll just say 4868, maybe 685. 48685. I like rounding out until I don't have to round up. All right, so that's those two parts of our equation. And then from here it gets really easy. So that was the most complicated thing was just finding those two answers there. So this one and this one, because now I can come back over here and I can solve this equation here for both projects A and B. So I'm going to say the EAA for project A and then the EAA for project B. And I'm going to say that's equal to the net present value of A divided by the present value of an annuity factor of A, right? And then this one is the net present value, of B divided by the present value of an annuity factor of B. So far, so good. So we're just basically, at this point, we're just plugging and chugging, right? So let's just go ahead and plug in those numbers. All right. All right, so we've got it that far. And so 10, 3, 3, 2, 6, 2 divided by 3.1698 equals 3,259.70. Oh, don't do that. We'll say 71. All right. And then the second one is 3,364.58. Okay. So now that we have those two answers, the question then becomes, well, how do we make our decision? Well, when we're using the equivalent annual annuity approach, it's the same as using the net present value approach. Whichever one is biggest is the one that we ultimately accept. And so in this case, project B has the higher equivalent annual annuity. And so if we were faced with these two projects, then we would select project B because it is greater than project A, which is good news, right? Because this was a second method for evaluating mutually exclusive projects with unequal lives, using all the same numbers, just a different method. And the good news is that both methods resulted in selecting project B, which just confirms that we are on the right track. And ladies and gentlemen, that is the end of this video. Take a breather. The next one's going to be pretty long as well. But hopefully this is helping you guys out. And if not, just let me know, shoot me an email, and we'll talk soon.